Okay, this is a demo of the 6P component of the next assignment. We'll start with a new game here. The key component of 6P is to build a state tree representing all possible games that can come from this particular shuffle. You can still play individually until you build a tree. When you build a tree, down here at the bottom, this in the interactions pane or in your terminal window or whatever, it generates some information about the amount of time it took to do the build and the results of the tree, which are there are 1,528 nodes, the tree depths of 63, and the score is 42, which means the best game you can get playing this is to get 42 cards. This particular shuffle is to get 42 cards to the discard pile. And now the program goes through the tree. A user cannot play because it messes up the tree. So we turn off and most of that code is most of the interaction code is written. You just have to write pieces to make sure the right thing is done. However, if you would like to, and in particular I wanted to, so we could, go to the end of the game, and you might like to, so here's your 42 cards in the stack, and let's replay this. I want to show some other things. So a couple things are going on here. The labels have had a new component added, which is, we can undo here. So this says that there are 52 in this stack, and the best score that we can get in this game is to get 42 to the discard pile. As we move, what's happening now is the labels at the top of each of the play decks are indicating what moves are in the tree at this point. And the rules of building the tree in order to minimize the complexity of the tree and the number of nodes in the tree are that we will not put a draw move into the tree if there is any other move that can be made. So the only move in the tree that can be made now is to move the jack of diamonds to the discard pile. So that label shows that this is a move, and that's the score that will come from that move. So we make that move. Now, the only legal move is a draw. So the second after the colon in the cards is, if you make this move now, that's the score you get. Well, it's the only move possible. And now here, the only move possible is the 5 of hearts. So here, that shows that 42 is the only move that we get from there, and so forth, until here we have an empty slot. An empty slot shows us that there are two possible moves. If we move the 3 of spades to the empty slot, the best score we'll get is 40. If we move the 6 of hearts to the empty slot, the best score we can get is 42. So clearly the move is chosen will be the better one. Now we only have one choice, which is to move the 3 of spades. Now the only choice is the draw, so we make it. And as we go through, here we have 3 choices. So this is, at this point in the tree, there are 3 children. Any one of these 3 can be moved to the empty slot, and so forth. So again, the GUI components are all there. You just have to fill in a little bit of code to make sure that once you build your tree, that you fill in the labels associated with each of these columns, each of these card decks, so that the GUI knows what to display here, which moves are available. So at any time, you can decide as you're walking through here that you want to try something out, you want to go into user mode. There's a checkbox down here which takes you out of automatic play mode and lets you go through the game as a user. I didn't do this so that the game stayed there. I might look to see how hard it would be to leave the game in the state and not restore it to beginning. Anyway, and similarly, if you're in user mode, you can't undo. There's no undo except for the tree. You can switch back to turn user mode off, and it'll build it. Oops, it'll build. It takes time. It'll build the tree again, and you can go back to play mode. There's no way. I don't want to get into the complexity of having in the middle of a user play to build a tree from then on. It may not be too hard, but I don't want to get into that. So there are other let's see if we can stop that. No, it didn't stop it in time. So there are other, let's replay this and do some moves. There are 3 other buttons here. Save tree will generate a file called that will be named for the seed in the game, and it will be a representation of the tree. I'll open up that a little later to see what it looks like. Log path says from this point in the tree, print out the path to the end node that will be the winning game of the tree. It gets pretty long here. It's not terribly useful from the beginning, but it's a debugging tool and a test tool. So from where we are now, the current node we're in is the play that placed draw the 4 cards here. So there's the, in parentheses, 7 diamonds, 3 of clubs, 10 of hearts, and king of diamonds. The next move, as we can see here, is the 7 of diamonds. After that's done, the 3 of clubs can move, and then the king of diamonds. And then we'll need another draw, and then there'll be the 10 of spades and the jack of spades and so forth. So that's log path. And it will also dump it to the log file, but if you're in interactive mode, which we will be, it will show the path here. Node stats will produce a variety of information. I'm going to add something to this. I haven't figured out all that I want you to do, but at this point in the game, what is the score of the winning game? How deep is it from here till the end of the how deep are you now in the tree, and how many children do you have? There's just one child here, so that shows up. If we do a move till we get to some choices here, we may be past too many choices. Once you get a number of cards on here, it's hard to get choices, because the only choices you have, the way the restrictions on the game are, is to have an empty slot. If we go back to the beginning here and get to so here we have a choice. If we do node stats there, we should see that there are 2 children. And I think there's one more move here. You can actually get 3. There we go. So we do node stats, and we see that there are 3 children. So that's a check. So those are 3 debugging tools, really. Generate a path from the current node in the tree to the leaf node represented by this winning move, statistics for that node, and a complete tree. Let me just show briefly. I will be adding some sample files. So the tree that we're doing is S0, G0, seed 0, game 0. And it will look something like this. In order to not, there are 5,000 nodes here, and I mean 1,500 nodes. The root of the tree has a score of 42. Most of the plays will just be either draw or play a card to the discard pile. So here we say the next play is to do a draw, and then you play J diamonds, and then there's a draw, and then you play the 5 of hearts and the 5 of diamonds. And only when we get to this place where there's more than one node, move possible, here's where that 3 of spades, if you took that path, you'd only get 40. And as we scroll down here, eventually, and that's the entire tree there, if you take the path 42, take the path of the 6 of hearts, you get 42. And so here we have a layout, and there is skeleton code that you will have in order to produce this output in exactly this form, as long as you give the information. This the braces here indicate that this is one of multiple choices, and the .5 is the depth at which this play is being made, and the piles are the draw, the 4 play piles, and the discard pile at this point in the game. And whenever you have a series of nodes in which there's only one child, you just list those plays in this compact format, providing the draw, the 4 of clubs, the draw, the 7 of diamonds. We don't list the actual cards chosen for the draw here. It's, again, this is a debugging tool so that you can help to follow along and see where your moves may end up being, your choices of building the tree may end up being different from mine. So, and I'll produce some examples of those like I did for 5P, the Yukon game. Okay, that should be all you need to know, hopefully.